With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is 1-phenyl 1-propene shows cis and trans isomerism. The cis and trans forms are also called as, see, we have to tell 1-phenyl propene, they show cis and trans, that means geometrical isomerism, but we need to tell that cis and trans forms are also known as what? Enantiomers, diastereomers, conformers, and position isomers. So let's see. Our 1-phenyl 1-propene structure of this is like this. It will be 1-phenyl. So if this is 1, 2 and 3, so to the carbon number 1 only, a phenyl group is attached. Right, this is a phenyl group. Another is hydrogen, and this double bond, CH and CH3. So this is our 1-phenyl 1-propene. 1-propene means at one carbon we have a double bond. Okay, so this is the structure of 1-phenyl 1-propene. It can show cis and trans isomerism. How? Now let's see. If I write this structure like this, if I write it like this, CH3. So this will become cis because see, if you give the priority, this is 1, this is 2. According to the atomic number, this is carbon, this is hydrogen. So it will get 1 and 2. Similarly, carbon, and this is hydrogen. So carbon has a higher atomic number than hydrogen. So thus, because it is 6 and it is 1, right? So it will, this is cis because 1 are on the same side, 2 are on the same side. Same groups, that is hydrogen and hydrogen, they are on the same side, right? So this is your cis. Now if you put same groups, that is hydrogen and hydrogen, opposite to each other, then that will be your trans. Okay, like this. So this is your trans isomer, right? Now if you see enantiomers. Now what are enantiomers? Enantiomers are nothing but the isomers which the compounds which are mirror images of each other, but non-superimposable. They are non-superimposable. Let me write this again. They are non-superimposable. That means you cannot impose over them over each other. Superimposable. So thus, but if you see these structures, if you see, do they look like that they are mirror images of each other? No, they are not mirror images of each other, and of course, since they are not mirror images of each other, they cannot be enantiomers. We see superimposable, non-superimposable condition later, but if you see, they are not even mirror images of each other. So they are not mirror images of each other, because so thus these are not enantiomers. So you cannot call them enantiomers. So A is incorrect. Conformation are they are the compounds which have the same attachment. You can say they have the same attachment or they have the same bonding. That means same attachment. That means carbon is attached to this. The bonding is same. That means if I say that this carbon is A, B, C, and then this carbon is there. Like this. This is a single bond, okay? And E, F, G. Like this. If I draw the another isomer of this compound, here I'm just taking an example to show you. Okay, so if you see the another isomer of this compound, what it will be look like? It will look like this. C, here B, here A. You just rotate them, okay? Because if you just rotate them, okay, on just rotation, these compounds can form the same structure. Alright, that means conformations are nothing but the isomers which the compounds which can give the same attachment on rotation. Alright, that means the compound on rotation will give you the same attachment. Alright, so if I give you one more example of conformation, because I think I should give one more. See here, if I take this example, let's say we have this Cl, hydrogen and hydrogen. Right, similarly, we have this hydrogen, Cl and hydrogen. If I have to write its conformation, let's say what I do is I rotate this like this. So what will be the isomer? It will become like this, hydrogen. Cl will come here and H will come here. Right? And this will remain same, this one will remain same, so you will get this. Right? So this and this structures, they are isomers of each other and they are conformations of each other. What you did is just see, here also CCl bond is there, here also CCl bond is there, CH bond is there, CH bond is there. The bonding is same, the attachment is same, but what happened is their position is changed by the simple rotation. So those are known as conformations. Okay, so because these two is having a double bond here, and because of the double bond leads to the restriction. Okay, it restricts the rotation, right? And thus this CH3 cannot be this bond cannot be rotated, and CH3 cannot come on the place of hydrogen by simple rotation. Why? Because of the double bond. Double bond is restricts the rotation. It will not let the simple rotation happening that is happening along the single bond. What happened is this is the single bond between this carbon and this carbon, right? So it was easy to rotate three other bonds by keeping one bond constant or fixed, right? But here it is a double bond. It restricts. This bond cannot be rotated. If you want to rotate this H and CH3, then you have to break their bonds first. Alright, because if they try to rotate, then this pi bond will be broken down. Okay, and here the pi bond is still there, so it cannot rotate, okay, because double bond restricts rotation. So that's why B is not the answer. Now if you see the diastereomers, what are diastereomers basically? Diastereomers are the compounds which are not mirror images of each other, right? They're not mirror images, and if you see, are these two mirror images? No, they are this cis and this trans. They're not mirror images of each other, because they're not mirror images of each other, and they have no relation. They are just cis and trans. What is changing here? The position of the atom is changing. Here it was downwards. CH3 was downwards. It was towards where the phenyl group was attached. Right, now it is away. It is opposite to it. Or you can say the HH were on the same side. Now they are on the different side. So this is what we tell the compounds. So thus we can say that yes, these two compounds are diastereomers of each other, because they are not mirror images of each other. They are not mirror images of each other. And because they are not mirror images, their only position is changing, right? And that too not by simple rotation, okay, by bond breaking. And another bond is by bond breaking. CH3 bond is breaking from here, H is bond from breaking from here, then H is forming here, then CH3 is forming here. So these type of compounds are what? They are known as diastereomers. And that's why geometrical isomers, because these cis and trans are geometrical isomers. Geometrical isomers are also known as diastereomers. They are also known as what? Diastereomers. Right, they are also known as diastereomers. So thus your option C is the correct answer. Position isomers? No, they are not position isomers, because for that the position of the function group has to be changed. And here no function group is there. Right, only double bond is there. Alright, so thus your D is also incorrect. Your correct answer is C, that is diastereomers. I hope you understood. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.